I'm Roman Babkin. I'm a lead data scientist at GlobalLogic. I'm PhD in theoretical physics. What else? I have almost 8 years experience in industry data science and like 15 years in academical research involving data science and machine learning. So I know a little about machine learning, about AI, and I want to share my knowledge, my experience with you, at least within this like 1.5 an hour. So this is the second my lecture. The previous lecture, the first my lecture, was about what is the machine learning, what is the AI, and how does it understand us. And I promised you, all of you, to proceed with my next lecture, explaining what is the role of the AI, real role of the AI, and how can we utilize the AI, and especially the LLM, large language models, chatbots, and so on, in our life. And basically, I want to explain it to you in such a manner of live coding. Um, it's not like a live coding. I will not code. I have the code already, but I will run each line of the code with you, and I will share the code with you afterwards with the presentation, and everyone can just do it by yourself. And I will explain you uh, each step, and the explanations will be in the presentation as well. So I will switch from presentation to the code and vice versa. So it will be like a marathon. Um, yeah. Okay, let's start. How to build your own chatbot from scratch. Um, this is the like not the whole name of this lecture, because the main idea of this lecture is to understand the place of the AI in our in the ecosystem around the surrounding of the AI, and basically build your own chatbot. Why not? It's a pretty cool stuff to talk to something. Yeah. Okay, let's start from the beginning. Let's think, how can we use our own AI? Uh, uh, do you see the screen? Yep. So, okay. The generative AI in the real world. What if I say, "Hey, AI, make me a sandwich"? Will it? I swear not. Even if I say pseudo, like I insist, will it? I believe no. But why? Frankly speaking, the main goal of the uh of the AI is not in making a sandwich, but in helping to do this. Let's create a generative sandwich generative AI. What are the main features? What are the main steps of this sandwich generation? So basically, the first one is obvious. It's we need to define what kind of sandwich do I or you want. If it's like a vegan sandwich or sausage sandwich, or if it's a hamburger, whatever. Uh, and definitely this is the work for the LLM. When we say define, when we say understand, it's a kind of work of the AI. So LLM, by LLM, I mean large language model, the model that lays like as the heart, it's a heart of all the generative text generative AIs. The second step is to generate or to find the proper recipe. So if I say generate the recipe for the, I don't know, such kind of sandwich with mushrooms, it can generate. Or if I say find it in internet, it will probably find. So I say if generate, it's again, it's a job that LLM can do. However, find, it means that the LLM should have a um, tool that can help to search through the internet. So we say tool. LLM can't by itself search through the internet. However, if we give it a proper tool, it will search by itself. So it's a kinda what LLM can do. Next step, go to the grocery store. No, there is no LLM, there is no AI which can go or order online. Again, if we have some tool that can help us, like the ordering tool, the LLM can create this order. Or find in a fridge. Nah, I tried. No, it doesn't. Optional. If I say I want this kind, if I say, sorry, I don't have these ingredients, you need to change the recipe. It's okay. It can change the recipe, and instead of sausages, it can give you some mushrooms and whatever. It can do this. This is basically what LLM does. But make a sandwich, you should do it by yourself. So okay, let's review again. Which steps are could be done by the LLM and which not? And if everyone can find that the steps with green are basically some intellectual steps which say let's create a text, let's change a text, let's do something with a text, with the information, and everything else, some physical, basically physical involvement, uh, it's not. So Uh, my previous lecture had a postscriptum, which I want to show you right now, and I insist that the current intelligence, AI, artificial intelligence, is not the basically intelligence. It's just a text generator. It's a very good, extremely powerful text generator. And the text generator can't create you the sandwich because it's basically the physical world. So what is the place of the LLM in the world? Um, let's say let's see some examples. Let's say the user asks a question um to make a search in a database. Okay, it's cool. It can do this. I say question, LLM goes to the some database with some tools, but it goes and takes the result and gives the answer. Okay, or I say something to the LLM. I say, just create me a image of the, I don't know, mountains, whatever. The LLM understands your task, your question. It converts it into some task to the image generator, and the image generator creates an image. Basically, right now we have some models that can do it together, but nevertheless, the idea is the following. The large language model here uh, acts as the translator from your native language into some mathematical or some logical computational computer steps, computer rules. So the LLM has its own unique place, and we can utilize this LLM with 100% when we use it in a proper place. When I said the LLM takes something that you say as the input and gives something to the output to the image generation model, I mean that we can use basically different models together. I can start with a text generator. So basically, it's not like a okay text generator that understands your language and creates some rules in the future. It can go to the math, and math can go to image, and so on. We can utilize multiple models in a row, or in a parallel, whatever, and they will translate. They will do their job. And I want to show you uh, how to use one of these models. I will focus on the text generators or on LLMs uh, in some kind of way of like mm, how to create some infrastructure around, how to utilize it in reality. Let's do some coding. Yes, I expect that all of you know the language Python. If not, I suggest start learning this because this is the very simple language and the most uh lots of artificial intelligent tools, they are written on the in the Python. So okay, I have these parts of the code in the presentation. However, I do have them also in the code. Uh, I will skip them and I will go to the code part immediately. However, I just want to stop here and explain some requirements. Before we start doing some job, we need to add some requirements. And my I apologize. My chatbot will be based on the LangChain framework. There are several frameworks of similar to LangChain, but LangChain is one of the most powerful and develop like it is under development right now. However, it has a lot of cool features that will help you to utilize any model that you any like such kind of generative model like 150% for sure. Also, I will use few more libraries like NumExpert or SymPy just for to create some tools. TikToken is one of the libraries that calculates tokens. I believe you are familiar with tokens, and tokens are just like we need to calculate them, not to hit the limit of the tokens that each model has. FAI as CPU, this is one of the several cool databases for LLMs. Um, this one was done by Facebook, but I sometimes I prefer this one, sometimes I prefer ChromaDB, but nevertheless, I will show with this. And Python.env is just a library to get some infrastructural environmental variables. Okay, uh, we'll have only one script called main.py, and basically let's go straight ahead. Here it is. Okay, preparation. I import a few of them. Also, I load some parameters from the .env file. Here I just put it this line. I commented this line because we will use the OpenAI API key, and I just put this API key to my .env file. However, I don't want to share this key. Sorry. So when you run it, just uncomment it and put your own API key here. So also we will use the 3.5 turbo model. And the encoding for TikToken, I choose as well the encoding for the same model. So let's start. I just started the engine and I executed everything here. Okay. Uh, let's initialize the LLM. Very simple. So LangChain has lots of um, pre-built not LLMs but integrations with LLMs, calls with LLMs, and I will use OpenAI and I will use exactly the chat OpenAI. There's some difference between chat OpenAI and OpenAI, but nothing special basically. So we shall initialize it with like this. So I just say OpenAI model, this one that I use. Then I say we don't need some callbacks, and I will explain what this part further, but right now I don't need. Streaming through, I just put here just to show you what's going on inside. If you don't need all that millions of rows of outputs, you just can say false. Temperature, we've talked about the temperature previously. I just put it 0.5. It will give me just good results, let's say. And max tokens output, since the 3.5 turbo has a limit of 4,000 tokens output and input, I just limited the output with this one, just not to hit the limit. It is quite good number just for tests. Okay, I initialized it and let's say hello world. I said LLM invoke hello. And the answer is, hello, how can I assist you? Oh, nice bot. Let's count. I used the encoder. By encoder, I mean the tick token encoder. And I know that I used 4 tokens as input and 9 tokens as output. Let's count. 1, 2, 3, and 4. Oh, cool. That's good. So it's a good way, it's a good rule of thumb, just to count your tokens and just to know what you used. Okay, and the last step of the preparation is we have this LLM. We have this, let's call it prompt. So this part is called prompt. So this is the whole instruction that we send to the LLM. So let's go further. Uh, there is a big, I would say, huge part of the LLM development. The part is called prompt engineering, and you can spend lots of time on during these activities. And basically, the idea of the prompt engineering is to fine-tune this prompt. So when I say hello world, it will just give me some answer. However, I want to do something with LLM. So the prompt is basically this is a programming language for the LLM. So again, LangChain has their own objects called prompts, prompt templates. By template, we say that we have a template of the prompt, and we can put some values inside. So I have a value question and I have a variable language. So let's see. Give response to the following question. What is the question? I don't know. I will put it after. I will reuse it several times. Be brief and give easy to understand responses. Your response should be in this language. Yeah. So my question is, who is Santa Claus? Uh, I can ask it in Spanish, or let's say Ukrainian. Let's do it. Why not? Uh, and let's run and let's see what is the prompt. Give response to the following question: Who is Santa? Be brief and give this blah 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 in Ukrainian. So you can fine tune this prompt. You can use the same template, but change these variables whatever you want. Okay, let's run. I say invoke Santa Claus, выгаданный человек, точно. It works. So I can ask it whatever. So just change your template, fine tune it, and basically add your parameters, whatever. This is a prompt template. This is the main tool that you will use to interact with the LLM. Okay, let's go next. Uh, yes. In some cases, the output of my output here in the code might be not the same because we have different temperatures, and so sorry, we have this temperature and the output might vary, but basically the idea is the same. Okay. So the next one. Previously, I said that the LLM is just a part of the ecosystem. So LLM is just something that helps us to translate the human language into some uh, computer understandable things. So how can we do this? Uh, there is one technique or idea called chain. So by the name chain, you may understand, you may just feel what is that. So chain is a sequence of calls. It doesn't mean that these calls are all to LLM. It's a sequence of calls, and one of these calls might be LLM, may not. Why not? So and the idea is every time you call it, you run this chain, and you use like every time, and you expect to have the same process every time. So let's check. Make sandwich. What is the chain to make sandwich? So we have a first make a sandwich. So next step is a get recipe, get ingredients. We go in parallel. So when we have ingredients and when we have steps from recipe, we go next, we start preparing. So this is a chain. And every time I say make a sandwich, the tool will walk through these steps and execute them. So yeah, definitely this is just a recipe of making a sandwich. However, you can imagine the same chain involving some LLMs or some programmatic techniques. So let's go next. Chains. Let's check what do we have so far. Again, LangChain has lots of predefined chains. Um, I will use the LLM math chain. So for those who didn't participate in my previous lecture, I need to say that the LLMs, they are very bad in math. They are the worst in math, word guys in math. And to do some math, they need some extra tools. So let's create a chain that can involve these tools into your communication. So I include the LLM math chain. This is a chain that already has some mathematical approaches, some mathematical tools inside. Then I create a prompt using the prompt template, like generate a simple math task for adding, and then it shall answer this question basically. So now I create this math chain and I create the main chain. The main chain is I create a prompt. Then next step, I use this LLM, and then I use the mathematical chain. So basically, my idea is the LLM will create the mathematical question, and the math chain will answer this question. Let's do this. Oh, I don't want to share this. Eh, okay, and invoke. Let's go. You see, since I said I want to show everything, all the steps are here. So the first step is I say apples, yes. Generate a simple math task for adding apples. Let's go. Chain run, we start running some inputs. Now we go here. LLM prompts human generate a simple math task for adding apples. Now LLM executes and gives the text back. If you have 5 apples and you buy 3 more apples, how many apples do you have in total? This is a question. The next step is to solve this. So you see, let's skip all these steps and go here. So the main one is um, if you have this much apples, blah blah blah, and the next step is to evaluate using the second math chain, and the answer is 8. So the answer is correct. It asked a question. Oh, you see here, it translated this question into numerical example. So it translated the text, the question that it already created by itself into something that Python can use. And then math chain creates the answer. Yeah. So you can create as long chain as you wish. You can create some logic here. If you don't have answer for this, do this and so on and so forth. Chain. It's cool. Okay. Uh, the next one. So chains are predefined. So imagine this is a set of steps. It's a script, Python script that helps you to run step by step, do something with LM and with all the tools. When you create a chain, you definitely know what you will do, what steps should be here, and you know this logic. Uh, Okay, this is the same. However, imagine I don't have this strict logic and I don't know what should I use? Should I use the math tool or should I use some translation tool or whatever? And in this case, chains will be very complicated, and it's like a programming. I need to create a program, a script that will cover all the business logic, all the logic. Uh, in this case, we have another tool called agent. So the core idea of agent is uh, to use the LLM, to utilize the LLM to understand what should it do. So previously we created a chain with the particular steps, but if we don't have these steps, LLM should understand what should it do. And uh, how does it work? The user asks a question, and this question goes to the LLM, so basically to the agent. And the agent, this agent has a some explanations of the tool that it has, and the agent asks LLM, "Hey, I have this question. I have this set of tools. What should I do?" And the LLM gives the response back. The agent translates, like not translates, but understands, let's say understands the answer and executes the say like executes this tool in that order. And even more, the LLM can give you even more. It understands what is the tool and what parameters does this tool require. And basically, LLM can generate these parameters, and the agent can use these generated parameters to execute each tool. And after that, we have the when all the tools are ready, we generate the response based on all that we have. And the text with oh yes, so it generates a script. What should you do? What should you use? And then LLM parses this and executes. Uh, Agents are extremely flexible. They are flexible as if the user, if the human, would sit here and do it by itself, by it himself. Uh, However, every time the agent does something, it asks a question to the LLM, and it increases the amount of tokens used, so payment. It can be extremely slow, because every time you ask the LLM, you wait for response, and the response is the API response and so on and so forth. So, and potentially unstable, because the longer chain the LLM this agent creates, the more problems it may have. So this field of AI is yet to be developed. So we are on the top of all that. So just be careful when you use agents, because if you start with a very complicated agent, it may fall. It may fall for sure. Okay. Basically, agents are some kind of parts of the chain. So we can use them as the part of the chain. Let's say here, this is a chain again. The user input, we can say write this to file, and then we put the agent. Instead of programming if else, we say here would be agent, and here you see here you have these kind of tools: Python programmer, poetry, Wikipedia expert, image creator, legal expert, whatever you want, mathematical, whatever. And the agent should choose what should it use, or maybe several times, several tools. If I say create me a program, Python program as a poetry, as the poem, and it will use the poem and the programming, and so anything amazing. After the agent executes all these all required steps, we go to the response to user. And basically we can write a file, whatever. So this is a chain. However, we have a part of this chain that executes by itself, and it understands what to do. So instead of our predefined hard-coded programming, we we rely on agent. Okay, let's go code in. So agents and tools. Uh, Before you execute agent, you need to create tools. Yes, because agent without tools is just a step in a chain. Okay. I created prompt. I created some another type of prompt. This prompt is based on messages, and each message has a role and basically the question or some instruction. So the system instruction, I say, yeah, helpful assistant. Why not? Then I have a human. This is a question from human. And the placeholder is basically for tools, you need to have this role, and tools will understand what sorry for agents, and the agent will understand everything that inside these brackets. Okay, what tools do I have? I have Wikipedia tool. It is I can call it with the Wikipedia API wrapper. So the tool can be even a API call. I can call any API and I can call it tool. Why not? The only thing I need to have a description of this tool because the LLM will use this description and decide whether it should use this tool or not. And basically the function that I run, in this case, it will utilize only one text, but if you have something more significant, you have lots of variables, you need to explain these variables here and add them here. Okay, and also I created tool set. It's a list of all tools, Wikipedia tools tool, and I have another way how to create a tool. I just load uh, tools from predefined tools of the lang chain. Also, I can create my own tools as a Python functions. It's a pretty simple, but again, it's a pretty simple. I just want to have this Wikipedia tool and math tool. Also, I create an agent. I need to create agent and say use this set of tool, use this LLM, and this is the prompt. And also I have a agent executor. It's a funny, but every time the long chain updates, it provides some new techniques and some few steps before, a few generations before, there were no executors, and I could execute agent just from scratch. However, they said that it's a good way to do this. I will not argue with it. So we create an agent and then we create an executor. Again, we say this agent you need to use and these two set of tools. And also I put here the verbose true just to show you how does it work. Okay, tools. I have tools, I have agents, and I created these agents. And let's execute them. So I say add radius of Earth to radius of Moon and multiply it by 2. So my idea is first it should go to the Wikipedia and get what is the radius of Earth. Then go again to Wikipedia and ask what is the radius of Moon, and then use the math tool just for the multiplication and sum. Some add, and multiply. Let's go. Let's run. And basically, okay, calculation. It goes Wikipedia with radius. This is the result of Wikipedia. So this is a text from Wikipedia with some, I believe it's a Earth and I don't know, radius, I don't know. So basically this is the text from Wikipedia. Then LLM reads this text, page moon, you see page moon, page Earth, and then it says radius of Earth is this. Oh, sorry, somewhere, and then it uses the math tool. Multiplied by is this. Um, yeah. So let's say the output. The output gives me the sum of the radius, blah blah blah, with some parameters and so on. So all that is a dialogue between agent and the LLM and tools, basically. For some reason, it didn't show me. Maybe I had to put here verbose as well, but nevertheless, it should show all that prompts and all that thoughts of LLM when it says go to calculator, go to Wikipedia, and so on. However, there is one more tricky part with agents that when we use agents, the output of the LLM is everything here. This is the output of the LLM. And you need to programmatically get only the output of this. So in LangChain in LangChain agents, we can do it by the LangChain. We can say just give me just the answer. However, sometimes some thoughts and some previous steps can be outputted to the output of the agent, and we need to be careful and carefully check if there are extra information, because definitely user doesn't want to listen to some thoughts of LLM. The user just wants to know what is the answer, and that's all. Okay, so again, uh, we implemented two tools and we asked the question, and the agent made this decision by itself. I can even not ask the Wikipedia. I can just ask the question about what would be 2 plus 2, or I don't know. And it will go directly to the calculator. Uh, so it's again the logic of using or not using the tool. Okay, let's go. Let's go next. Whew. Um, it is again, it is the same. The same we have. Uh, okay, this is the basically I put here uh the real thoughts of the agent. So uh this first I need to know the radius of, so this is the answer from LLM to agent. Now, this is the action language model. So I have a language model or I have a Wikipedia model. In my case, when I run it went to language model. And observation means that so this green is the answer for of the LLM to the tool or to the agent. Then agent by using these predefined words, it went to actions. And this is the observation from Wikipedia. Now, this is the next step, asking what should we do with this? The LLM gives, you need to go to the calculator and do this. The calculator gave this. And after that, the LLM gives these thoughts. Now I know the final answer. So we programmed it to give the final answer. And then the final answer is this. And we can cut this whole dialog, just cut by this final answer and see only the answer. So if you don't want to show to user all that, you need to carefully define what would be the trigger of the final answer. So yeah. Let's go next. Conversational memory and chat. Okay, previously we had these kind of these kind of steps chain. However, when I said make it sandwich and I got the sandwich, that's all. We are done. When I say give me once more, it will not understand what I want, because the next time I ask this, it is then another instance, another dialogue. So we don't want to waste to lose our history and the history of our conversation as we do right now with you. So you remember what I said a few minutes ago. So that's how the conversation works. And in AI, we do have also this conversational memory. And imagine, like, again, what is that? With the conversational memory, I can ask a questions, get the answers, ask a questions based on the answers and so on. And after that, ask a question like, what is the LLM? What is the chatbot? And what is the best one? Imagine if I had no conversational memory. the LLM would say, I'm sorry, what are you talking about? What is the best one? However, if I have the conversational memory, the LLM would understand this. But again, the LLM will never you like LLM doesn't know what is the memory. We need to give it to it. So again, the LLM is just a text generator based on only one instance, and we know we need to somehow to add the history to our prompt. So there are lots of techniques. How can we add this information to the prompt? Because LLM gives the answer just only on one prompt, no more, no less, and we need to add all the information there. So the main idea is just to put everything together and take everything and put it into the prompt. However, the history might be very long, so we spent 45 minutes of my monologue, and I definitely can't put all that information into the LLM because the LLM has its own restrictions, its own limitations. But I want to have this history. So let's think, how can we there are lots of techniques. I will show you a few of them. First of all is a conversational buffer memory. Let's say I take only last three dialogue pairs, not more. Everything previously I will just skip. And the chat will remember only what we were talking about few minutes ago during these minutes. The second one is the summary memory. So when I take my history and somehow summarize it, instead of thousands of words, I just say we were talking about LLMs, we were talking about agents, and nothing more special. I showed some code. We decreased the amounts of tokens of information into some very simple, or we can define what length of this information we can do. However, we lose details. We have very general idea, but we lose details. We can use conversational summary buffer memory. So let's say I use previous several steps as they are, just to not to lose the details of our previous dialogue steps. And everything that was previously, I just summarize. There are lots of other conversational entity memory, so it will remember just, it will do some tags. They were talking about LM, agents, uh, whatever. It just takes searches for entities and just tracks all these entities like tags. Knowledge graph memory, it's more complicated techniques that creates a knowledge graph based on all that we were discussed previously and use this as the part of the memory. Uh, Again, this one is quite like it depends on what you want. If you want just a like ChatGPT knows a lot. When you talk to it, it can remember a lot. However, after several huge steps, huge outputs, it can forgot what you were talking about previously. I believe they use something like conversational buffer memory. But nevertheless, you need to know your own purposes of your chat and basically use your own like way to use the memory. Let's go. Let's do some coding. Okay. Conversational memory again. LLM is quite a um useful and full of tools framework, and it has lots of different memories. Like here, I use conversational buffer memory, and let's say I take the buffer memory. I have the conversational chain. It's a predefined chain that has that knows that it's a chat. Now I create this memory. Uh, so sorry, I create this chain. I say use this LLM predefined in the previous steps, conversational buffer memory as the memory, and I say I don't want to verb. I can show you what's inside, but I don't think it's a very interesting. Now let's say Previously, when I used the LLM, if I say hi, it would say, hi, hello, how can I assist you today? And then if I say this, what was my previous message? It would say, sorry, I don't have information about the history and so on. Please specify a question. But if I do this using the conversational memory with it will definitely remember. Let's do this. Let's start. Hello, how are you? And your previous message was hi. Definitely hi. Uh let's check LLM. Oh, sorry. LLM invoke hello world. Let's do this. It says, "Hello world, how can I assist you today?" And now what was my previous question? Um, your previous question, was what is the capital of France? Sometimes it happens because we set 0.5 temperature, and it may give some very odd answers. So again, here I use the conversational memory, and here I use the pure LLM invoke um, question to the LM. So it doesn't remember you. So every time it's like every time in you guy. Um, okay, very simple. You can play with different memories as you wish. It depends on your purposes. Let's go back. Um, yeah, again, hi, hello. Very, very useful technique. And basically, I had lots of projects with the generative AI, and all that projects involved the RAG or retrieval augmented generation. So let's step back and discuss how does the LLM get the information. So the LLM, let's say GPT 3.5 or GPT-4, they were pre-trained on the whole internet, on the billions of texts, on the billions of tokens. And basically, it means that everything that they saw, that they read, they can reproduce. Let's say if I ask a pure LLM who is Roman Babkin, it will definitely not know because I'm not a public person, and information about myself, I can hardly imagine that some information about me can be inside of this model. Uh, However, we do need to use these LLMs with some our own information. Imagine you have your own database. Imagine you have a company, and this company has some information about users, or information about some policies inside of company, and you don't want to share this information with the LLM, with the OpenAI or whatever provider you have. However, you want the LLM to know this information. In this case, we use RAG. So how does it work? Uh, we have our own data. If it's a document, if it's a database, if it's some API call, whatever, if it's a structured information, unstructured information, or programmatic information, then we convert this information in in something called indexes. So it is again vectorization of the information that we have with adding some information about the source that we use. So imagine you have a database, you convert this database in some embeddings. And then when user asks a question, first you don't go to the LLM, because you definitely know that the LLM will not answer you. But first you go to this index with this query, and you search for the information that is very similar to your query, using some similarities techniques or something. I will explain just a little bit further. And basically, this vector storage, remember we discussed, I said face or a ChromaDB. This is a vector storage that stores your own private information in some way. How can we search through it very, very fast? And then we search through the whole your database for this information. We detect several documents or images or whatever that can be useful, that can potentially have the information that answers this question. We take this information, the relevant data, we have the prompt that says, hey, LLM, there is a user query and there is a relevant information. Just use the relevant information to answer your question. And we put it to the LLM. And in this case, if we really have this strict prompt, the LLM will not use its own knowledge. Instead, it will use the information in the data, the relevant information, and it will create the response. So it's a kind of chain that has only two steps: get the information and translate this information, like get the main idea of this information, answer this question based on this information, and give it to the user. So in this case, LLM may give its own thoughts, may add its own data, or it will be restricted. It's up to you. But again, the idea is you do not train the LLM based on your data, your private data. Instead, you just uh, keep your own data on your storage. You can update it basically every time, every second, whatever. Your information is every time up to date. The LLM may not be up to date. The last one, it's like April API. So on April, it was the last retraining. Oh, I remember. So everything after the April 2024, the LM doesn't know. I'm talking about GPT. Okay, oh yeah, what is the vector database? The vector database is basically the same to the database. However, it stores, instead of key-value pairs, documents, some graphs, it stores the vectors. The embedding vectors, for those who remember my previous lecture, you know what I'm talking about. For those who don't know, uh, vector is the representation of your part of your text or token or image or whatever as the mathematical object, a vector. So you have a content, you split this content into chunks because the whole content may not fit into the LLM token limit. Then you have this embedding model. This embedding model translates each chunk into some vector, something called vector, and then this vector is just stored here, and we each vector remembers with some metadata what was the document or image that it used previously. And yeah, we store it in the vector database. Why it is so? Why do we need this? Because the search through documents, through text, is quite a tough stuff. However, search through vectors is a mathematical step. Search through vectors is just a search through, let's say I have a question. Yes, I have a question. I translate this question into a vector and then into this embedding vector. And then I just search for vectors that are very similar to my vector. They're not exactly, because if they exact, it means that this question is already here. But I mean that this vector may contain the vectors in the database may contain the information that relevant to the vector question. How can we define if it's relevant or no, or not? We have n-dimensional space. So each vector is n-dimensional vector, and it has n columns. And if you represent this each vector as a point, as a dot in the n-dimensional space, you would see that some documents are far from each other, some are they're close. But let's say we have a target question, and when we put it into the same n-dimensional space, we may expect that some points, some documents may be close to our target. By close, I mean some similarity, vector similarities from linear algebra. Uh, I definitely use cosine similarity, but you can use your own and define which vector is close to yours. You can say, give me 10 documents or 3 documents or the closest one document. It's up to you. It depends on the accuracy that you want to have and so on and so forth. Okay. Uh, let's create this vector storage. Um, yeah. Again, uh, as the data set, I want to use.
I think we lost Roman just a little bit. We have to have patience, like 2 minutes, please.
Do you hear me? Could someone
Yes,
say?
we hear you.
Oh, sorry. I apologize. I have power outage. I had to switch to another network. But I believe we'll do this. Okay. Do you see my screen still?
Yes, we can.
Is that a story with a text? Am I right?
No, no. I think you need to reshare it.
It's a good story. How can I reshare it? Oh, because my second monitor went down, and I think uh that possibility to share. Um, I'm not sure if I can do this, unfortunately. Hmm. Can someone stop my sharing?
We'll try, yes.
Mm-hmm. Please, because the control panel, I just lost it. Um, maybe go out and enter again.
It's okay
Oh,
now? I
oh,
think I managed.
yes.
Sorry,
Many,
I stopped your video personally.
many thanks. Okay, let's do this. Share my screen. Okay, cool. Now you see the text.
Yeah, it's
All
okay
right.
now. Yeah.
Oh, great. Okay, for the text for the data source, I used to I just used the story, the um Snow White story about the dwarves and so on. Just a story. I know that the LLM should know this story. However, I will ask a very specific question about this text, and I don't think that this question will be answered just via LLM by itself. Okay, what should I do? Conversation vector storage. Okay, what do we have here? What do we have here? So we have a document loader, text loader. It's just I can do it by myself in a Python, but I am a lazy guy. I just use the this long chain functionality. Okay, I use embeddings, OpenAI embeddings, and basically, in some cases, you may want the database to have the same embedder as your model. It will be faster to mix your to merge your questions and answers. Okay, text loader. I just load this story. I will put this story into the file that I will send you as well. You can use your own story, whatever. Now I have a characters text splitter. I need to split text into chunks. I say chunks should be 1,000 tokens each, and the chunk overlap should be 0. I can do, let's say let's do 100 tokens. It will be chunk a chunk. Again, character text. Oh, sorry, it's a character text splitting. Sorry, we split it by a symbol, not by token. There is a token text splitter. let's do it a character. Uh, Depending on your information, depending on your purposes, you may use more complicated splits because if you split character by character or token by token, you may expect that your chunk may have, let's say, half of the sentence and another half of the sentence will belong to another chunk. And chunks will not contain, like, the information inside of the chunk may be not relative to each other. So be patient and choosing this text splitter. Right now I will use this, but you may spend a lot of time during your uh, when you do this task to get the best splitter. Sometimes we use a splitter that reads the text and decides which part of this text should be put into separate chunks, and it means we involve the LLM and pay money for LLM. Now we split the document and we use the FAS just populate it. Let's do it. Let's go, let's go, let's go, let's go. It's reading, it's splitting, it's embedding. So I use OpenAI embeddings. And now I say, who said no? I dare not take it. I don't think if LLM can answer this because it's it's a very very strange question. And also I may say that the embedding contains the text as it is. So we just cut the document into pieces and store as it is. So when I search for the similarity and I say, give me the first content, it will give me just exact part of the text. It will not explain me that this text contains, it will give me exactly that text. Let's do this. And you see how fast. And we see this part of the text that contains the answer to this question. Who said no there? Somewhere it should be. Oh, yes. Sorry, the window is small. So you see, no, I dare take it. So it searches not uh token by token. I can rephrase this phase. I don't know even how to rephrase this. However, it really doesn't search for the exact tokens. Instead, it searches uh for the for the idea of this. Does this idea belong to this particular one? Yes, it does. So yeah, we found it, and we can use this text into and put it into the prompt and use it as the part of our prompt and ask questions to LLM and blah 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 and so on. So up to you. This is a very powerful technique. You can translate text, images, sounds, whatever you want, whatever this embedding can do. Uh, and you can mix your data sources, and nevertheless, you will always have updated information, and the LLM will always know what's going on outside. Whew. And the last one. The chatbot. Everything before I showed you is just a steps. It's not even steps. It's just a parts of the whole solution that you can, as the Lego constructor, use or not use. However, everything from above we can utilize for the chatbot. What is the chatbot? Basically, this is the in my personal opinion, it's like a assistant, like a Friday or Jarvis for the Iron Man, who can answer your questions, who can call someone, who can book some meetings. This this kind. So, and we need to know that it has access to our database, it has access to our tools, it has the history that it realizes who we are and what we were talking about during the previous hour or so. So let's do this. Very simple chatbot. However, the idea of it is fully like useful. What we have here, um, we use history runnable with message history. It's one of the types of history, types of it's a chain, I think, or agent. Nevertheless, one of the tools that we need, just chat message history. This is a type of history that will not say that you were talking about like this, but it will keep also the roles. Who said what? And then we have, I don't know why I put it here. I can delete it. Agent executor. What I will use the React agent. This is the agent that will start like it's a zero shot agent. So it means that we don't predefine something. We don't say some. There is a technique, so-called zero shot uh, question when we just ask a question without any other details, any examples, or like preheated when we show some examples how it should explain. No, we just say be yourself. Now, the prompts, this is another technique how to create a prompt. I use the LangChain Hub to pull it has lots of useful stuff. I like you can spend several days of reading documentation. And so this one is just a prompt predefined for this particular agent with chat, with the history and so on and so forth. Chat history, I use the chat message history with, I can say like messages are empty, but I can add any messages I want if I want to start with something. Some session ID, it's just up to you. Now I create the agent. We already saw it. So it's LLM tool set, and I use the same tool set as we used previously. If you remember, it's a Wikipedia and math. And now it's an agent executor. We execute it, uh, and I create this runnable with message history executor. So I use the agent executor. I define the session ID and I apply it to the chat history. So the chat will be this history will be populated via the session ID and some message keys, what I want to, like some predefined parameters. Let's do this. Ooh, it's hot here. Oh, cool. Now I want to say hello. And also, if you remember, we said invoke and say, but now we need to keep this configuration so the message history will be updated. It says, hello, how can I assist you? So I will show you the thoughts and also this output. Okay, how are you? How are you? What you will answer? Oh, I'm just a machine learning model, so I don't have feelings. It's so depressive. How many people live in Antarctica? In this case, it should go to the Wikipedia. You see? Oh, and this is the Wikipedia page about Antarctica, and the summary is approximately 4,000 people live in Antarctica. Now let's ask another question. What was my first question? No, it will. Um, your previous question. Oh, there you go. Your first question was how many people live in Antarctica? And basically, like I spent not so much time on doing this. So it's after question, it thought that I need the answer on this question, and it again went to the Wikipedia and gave me the answer. However, it could say that it could search for the answer in the history. So I can say I can type the prompt. So if you need the answer, like use your previous answers to answer my next question and so on and so forth. So as you can see, we created in a few lines, we created a chatbot that first executes some tools. It knows our history, and basically we can easily add the RAG as extra tool here. Whew, I'm done. Yeah.
Thank you, Roman. We can proceed to the two questions we have.
Okay, I will uh answer these questions. Okay, where could we get OpenAI API keys? Obviously in the OpenAI page. So when you go to the OpenAI, you can go via the chat GPT or somehow you can like walking surfing, you can get the development page, and there you can set up your own keys. As far as I remember, when you sign in, you receive $5 free model, whatever model you want. However, if you use 3.5 $5, it's quite incredible amount of money. However, if you use GPT 4 Turbo, it will just immediately you will spend it. So API keys they expect that you will pay money, or in some cases, I know that some of you are students and you can ask your university or your institute for the API key, or even you can send a mail to OpenAI saying that you're a student, and they will give you a free credit. So basically, you need to show your student ID or something like that. But nevertheless, there are lots of different ways how can you purchase the API keys. But nevertheless, if you are interested in the development, I would suggest you just pay those $5 in a month for the OpenAI keys. It will give you free hands, and it will give you lots of possibilities to work with. Um, okay, done. Oh, sorry, I need to click it. Answer Live. It is it is agents who used to censure, execute bias, and check all the kinds of LM outputs. Uh, I think you are talking about the uh, ChatGPT. Basically, ChatGPT is basically chat, what we had here, and yeah, they rely on the GPT-4 model, which doesn't have anything except of its own. And yes, you are right. Um, ChatGPT does have agents so far. I believe yes. The last version 4.0 Omni, it can even search through internet. So I believe they have agents. However, 3.5 does have prompts around of your prompt. So they do not have they didn't put the agents. However, they put some prompts around. So when you type "Hey, hello," they add a lot of different instructions. Let's say, do not be polite. Do not answer some provocative questions, and so on and so forth. What are you talking about is in ChatGPT is prompts, instructions, systematic instructions. And I've read about a guy who saw those instructions. If you can play, basically you can play with the ChatGPT 3.5 and ask for the instruction. It will say, no, I will not give you the instruction, but you can get. So you can insist and somehow tune in your prompt, get the instruction, and understand what is the real instruction of the ChatGPT, and why can't you have jokes about women, let's say. Done. But again, you can create your own chatbot with the agents. Yes, for sure. Done. Answer. Can we use OLAMA instead of ChatGPT? Uh, no, because OLAMA is the model and ChatGPT is the chat. The ChatGPT is based on GPT model. And if I rephrase your question, can we use the OLAMA instead of GPT-4? Yes, you can. You can use any model you want. Basically, if you go to the documentation, long-chain documentation, you would see that they have APIs to a very incredible amount of models. Also, please consider Hugging Face library. They have lots of models as well, and you can plug in any model from the Hugging Face into the long chain, and you can utilize this. Uh, just talking about Llama, I do prefer GPT because it's much better. Whatever, I had lots of tests with Llama, with Bart, with Falcon, with lots of, and GPT is much better, but expensive. Okay, done. Next, why GPT is sometimes answering at the questions what I didn't ask? Oh, are you talking about GPT or ChatGPT? Again, it depends on the temperature that you put. If you put the very high temperature, it will just give nonsense. Uh, mm, it's a fluctuations. Since each model is the statistical model, it depends on probabilities. And if you give a high temperature, it will give high probabilities to various words tokens. And basically, if let's say you're talking about ChatGPT, it may consider previous your questions as the part of your current questions. So remember chat conversation memory. So if you don't want to include your previous questions and the answers of LLM, just create a new dialog in the ChatGPT. It will just delete all the history and start from the beginning. Typically, when I start, like I use ChatGPT for my research job and for some programmatic. If I don't know how to create some function, I ask it, and if I ask another question at the same next, it will consider the previous question as the part of my next question, and it may give me the code with some ugly code based on the previous one. So it's insane. So, but if you want to have very precise, just keep your history clean and define the proper temperature. Done. When I say to continue, oh, sorry. Yes. Okay. There are multiple. I know. Um, Probably if you don't have history. Also, if your question was very like let's say ChatGPT has its own limit of tokens. And if the answer of the LLM was very long, and you say, please continue, it will not have all the previous information in the memory because you know all these tokens, if you put them into the next question, you will not have the tokens to the output. So it sometimes if you say continue, it doesn't remember what was previously, and it may even doesn't remember what was your question because uh, the limit of tokens is like the amount of tokens is quite huge. Okay. But again, it depends on various things, and each particular question, each particular like I don't know. You need to dig into your situation, and there might be lots of answers for them. Okay, you mentioned a few times that LLM uses Wikipedia to search for some info. How does the LLM know about Wikipedia, and does the LLM do real call to Wikipedia? I showed the to all of you the tool called Wikipedia tool. Here it is, here it is, here it is. Uh, Wikipedia tool. Here it is. So LLM doesn't know. It knows what is Wikipedia because let's say if we talk about GPT-4, it was trained on internet and Wikipedia is a part of internet for sure. So if you ask a pure GPT what is Wikipedia, it will answer. However, if we're talking about the direct call to the Wikipedia, yes, here it is. So we use the agent, we use the tool Wikipedia wrapper, API wrapper, and using this tool, the LLM goes to the Wikipedia. Without this tool, the pure LLM will never do this. Uh, in a current world, I played with GPT-4o, ChatGPT based on 4o, and it searched. So it already has a tool behind the like behind the chat, and definitely this tool may go to Wikipedia or search in the Google or whatever. But your question is LLM uses Wikipedia wiki page. It can use the wiki page only if it was pre-trained on this. So GPT-4 and 3.5 was, so it can utilize the knowledge from this, but it will not search, definitely. I answered. Um, okay. Okay, cool. Uh, is vector search stable enough when you have huge amount of different documents for RAG, or it is more common to use knowledge graphs? Okay, this is the perfect question. Thank you. Um, uh, it depends on how do you do this. Basically, when I said when you cut it into chunks, uh, it depends. Like you can cut this information uh, imagine you have a document that contains some recipe, then some mathematical formula, then some French phrase, whatever, whatever. And when you cut by tokens, you may expect that your chunk may contain all that information. And in this case, the vector of this noise, of this vinaigrette, will will be very, very noisy. And even if you ask a question about the mathematical formula, this vector containing all the stuff will never give a good match with your question. However, if you apply some more robust chunking and you split into real information, and if the chunk will contain exact information that you want to keep in this chunk, your vector search will be very accurate and it will be very fast. And basically, knowledge graph, it's okay. However, how can you define the knowledge graph for text, sound, video, and images at the same time? You need to explain somehow the image, you need to explain somehow the video, and so on and so forth. But embedding is quite simple. You have the embedding model that can embed both images and let's say text into the same mathematical representation, the same embedding space, and then search through this will be just quite fast. Uh, I really faced lots of problems with the vector search with the RAG, and people said we don't like RAG because it's useless. I just said that you don't know how to work with this. First you need a very good chunking and then embedding. And it's after that, after you fix this, your RAG becomes just amazing. Done. Um, Anything else?
Roman, we received some comment from our participants asking if you can share the files and the presentation with them. Do you think it's
Yes.
possible?
Not right now because Zoom doesn't give this possibilities. But yes, we will share the presentation and files. I said that at the beginning that I will give you lecture main, I mean IPNB and requirements, and the story. If you want, I can skip the story, but it's quite a good fairy tale for minors. Yes, I will share for sure. So this is the only thing is without this you can't do anything. So you have to use this one. Have to uh, get somewhere your API. Or if you want, you can just not use OpenAI, but use something else. Just go to the long chain documentation and change my code accordingly, not to use OpenAI, but use, let's say, predefined model. You can run the model, very small model on your own on premises, or use Hugging Face servers to run something else. So again, up to you. But again, this code will be shared with you for sure.
Okay, thank you. We want to thank you, Roman, for this great presentation full of very useful information. I would like to share my screen a little bit because we still have some information to share with our participants. Can you tell me if it's okay?
I can see it.
Okay. Just a few more information, how we can stay in touch. I want to ask you to send us all your questions and proposals and at the email you see listed on my slide. Also, if you want to stay informed about our future initiatives, you can register using the QR code you see on the slide, and we will contact you with all the information. And a short reminder about tomorrow's webinar. It will be our last one, ethical consideration in AI. So I hope we will see you all there. And I want to thank you again, Roman, for your wonderful presentations, and to all our participants for their active involvement and for joining us today, sorry. And enjoy your evening, and we really look forward to see you tomorrow. Thank you.
Thank you. A good day.
Bye bye. Have a great evening.